All right, welcome everyone. Thanks for joining this webinar. So this is going to be a Java developer's primer to the Typesafe platform. I'm James Ward with Typesafe, and thanks for attending. So here's our agenda for today. I want to start out talking a little bit about Reactive and the Typesafe Reactive platform. Then we'll dive into the details, talk about Typesafe Activator, and I'll show you how to get started with that. And I'll show you Play Framework and walk through how to use Play Framework with Java. Then go into Akka and talk about using Akka with Java and actors. And then I'll go into some of the tools and ecosystem around the Typesafe platform. Then I'll show you an example of combining Play, Akka, and Java. And then at the end, we'll have some time for questions. So that's where we're headed. So let's do it. So first of all, I want to start out talking about software. Software is changing. The way we build software is changing. The way users use software is changing. And really the core of this change is that software is becoming reactive. There's 4 different tenets of reactive software. Reactive software is event-driven, meaning it reacts to events. It's scalable. It reacts to load. It's resilient. Reacts to failure, and it's responsive. It reacts to users. So reactive software is a new category of software. It's something that's emerging and some ideas that have been around for a long time but are coalescing into something called reactive. Recently, some leaders in the software development space, Jonas Bonner and some others, created the Reactive Manifesto, and you can find that on reactivemanifesto.org. And the idea of the Reactive Manifesto is to really put some meat behind these ideas of reactive and try to describe what reactive is all about. It's a technology agnostic view of reactive. And so I'd encourage you, if you want to learn more about reactive and what that's all about, check out the Reactive Manifesto. You'll be seeing reactive kind of weaved into a number of parts of the presentation today. You'll see those tenets coming out in code, and you'll see how the actor model and how play embody reactive. But I encourage you to check out the Reactive Manifesto if you want to learn more about that. So let's talk about the Typesafe Reactive platform. What the Typesafe Reactive platform is providing a way to have the productivity of like a Ruby on Rails environment and the performance of Java. So really trying to combine the best of both of those worlds into a platform. And what we found is that our users really do enjoy being able to work with a type-safe language like Java and being able to have the productivity and quick iterations that you have something like a Ruby on Rails. So in the Typesafe platform, when the way that it works to use the platform and what the platform looks like is you want to go reactive. You want to build a HTML5 site or build a mobile application or bring real-time into your software, or you want to use big data or NoSQL, or you just want better productivity and performance and better scalability. So something is probably driving you to go reactive. There's something kind of new in your software world, and so you want to go reactive. And so the way that you do that is you'll create a new application with Typesafe Activator. This is a new product that we just released the 1.0 of, and you'll start with a template. There's now 32 template applications in Activator that you can get started with, and you'll use Activator now as the way to get started building reactive applications. So you'll build those reactive applications with Java. You could also use Scala if you want, and you'll use the JDK tools and libraries that you're familiar with. And then you'll deploy these applications on the JVM. They'll use Akka for managing concurrency and using that actor model, and then Play Framework for being the web front end to the application. So you could build RESTful services with Play as well. So that's kind of a high level of what it looks like to go reactive on the Typesafe Reactive platform. So let me give a little bit more detail about Typesafe Activator. So Typesafe Activator is a web-based application. It's a local running web-based application. So you download it, run the web server locally, and then you can get started building applications. And we'll see that in a little bit. But in Activator, you can walk through the code. There's a tutorial for each of the template applications, and you can run the application, you can run the tests, all from a nice web UI. You can also pull your application from Activator into a traditional IDE like Eclipse or IntelliJ and work with the code in that type of environment and still use Activator to run the application. Typesafe Activator also has support for the Typesafe console, which we'll see towards the end. So let's dive a little bit further down the stack into Play Framework. So Play Framework is the high-velocity web framework for Java and Scala. And one of its core features is that it's developer-friendly. It has this hit refresh workflow where when you make changes to your code, you just hit refresh in your browser and you instantly see your changes. This makes for quick iteration, so you don't have to wait for WAR files to be rebuilt and Tomcat to be restarted. You just hit refresh in your browser and you're seeing your latest code. So this makes for a really developer-friendly environment. Also, there's some powerful tools, build tools, there's type safety. This is really one of the key values of the Typesafe platform is that we're built on type-safe languages. We let the compiler do work for us, and so that we can manage large code bases more easily. If we need to refactor code, the compiler is going to tell us if we've messed anything up. Also, there's great testing support in Play, and of course, support for building Play applications in IDEs like Eclipse and IntelliJ. Play supports the modern web and mobile app space. It's RESTful by default, so if you're building REST endpoints for mobile apps or for JavaScript applications, that is just the way the Play works out of the box. Also, it has asset compilers for CoffeeScript, Less, and other things. So if you need to compile something down into JavaScript or CSS, you can do that in a built-in way. JSON is a first-class citizen in Play, so you don't have to do anything special to get JSON. It's just there by default. Play also supports some of the modern protocols for doing push, like WebSockets and Comet, event source, which is server-sent events, and so this makes it so you can really integrate real-time into your application, and you can do this in a really scalable way because Play is built on a system called Java NIO, which makes it work really well when you have a high number of concurrent connections. Also, there's extensive support for NoSQL and big data. Lastly, Play can scale predictably. So underneath the covers, it has a reactive model that's built on top of Akka, and when you combine that with being stateless, you can scale Play horizontally, and we have a number of customers like LinkedIn and Gawker who are using Play at really high scale and having really great success with that. So with that, before we dive into Akka, I want to actually dive into a Play application. So to do that, I have Activator up and running. To get to this point, all you have to do is download the Activator zip file, open it up, and then launch Activator. So what I'm going to do is create a new application. You can choose from any templates that we have here in Activator. You can also go browse a full catalog. We now have 32 templates inside of Activator. So the one that I'm going to use today is going to be this, let's see, it's Play, and it's a Play example with Spring. So there it is, Play Java Spring. So the ID of the template is Play Java Spring. So I want to show how there's a lot of Java developers who are using Spring frameworks. I wanted to show how you can combine Play with Java and Spring to get started. And I'm going to come and select to put this on my desktop. So I'll select that, and then I just hit Create. So when I hit Create, what's happened is there's now a template for this application that has been copied, and now I have an application that I can start working on and using. You'll see that on the right there's a tutorial. This tutorial is under construction, so it's not quite done yet, but feel free to read through it and check it out on your own time. That's your homework for today. And then the rest of Activator, let me show you that. So in Activator, we can browse through the code. We'll be doing that more in a little bit. We can see the compile output as the application is being compiled. Activator will also run the tests that are part of this application, and then it will also run the application. So it'll take a minute for this application to get all started up, compiled and started up, but while that's happening, let me go back to the code and show you some of the code for this application. So this is a Play framework application, and it has a structure to how everything is built, and let me walk you through some of the pieces of that. So first of all, we have a build.spt file. This build.spt defines the dependencies of the application and any of the build configuration that we have in this application. In particular, build.spt is where I have defined my dependencies on Spring and Hibernate, which I'm using for persistence. Then there's a few other directories in here. There's an app directory, that's my main source directory. We'll go into that in a little bit. There's a conf directory where my configuration is. We'll see some of that in a little bit. Project has some additional build configuration information. Public is any static assets that my web application uses, and test is my main source directory for my tests. So it looks like my application is now up and running. Let's go check it out. So I can just open this up here in my browser to localhost 9000, and what we'll see there is here's my application. What it has is a very, very basic UI for this one, but it allows me to add new bars into the system, so I can just create those there. So not the most exciting application, but it really kind of shows in the code how we get started with Play and Java and Spring. So let's actually dive into that code. So the first thing I want to take a look at is the routes file. So in Play, what we do is we define a mapping between an HTTP verb and a path, and then the code that's actually going to handle that request. So you'll see in this conf routes file, we're saying for a get request to slash, handle that request with the controllers.application.index. And we prefix this @ sign here to actually indicate that this is going to be used dependency injection. The default in Play without the @ sign is to use a static method, but this time we're actually using dependency injection through Spring. You could also use other dependency injection, or you could just use the standard static methods as well, up to you which way you want to go. So that's how we define our mapping and our URL routing. Of course, these URL routes can have the RESTful style parameterization to them. You can do regex and all sorts of other fancy things in the path matching. So let me show you how we set up Spring in this application. So if I go into app and then go into global.java, this is where I create the Spring context for this application. So what I'm doing is when the Play server starts up, Play has its own server. It doesn't use a traditional container. And so when the Play server starts up, what I'm doing is I'm creating a new container, a new Spring container, and I'm using the Java config in Spring as a way to configure that container. You could, of course, also use the XML-based config as the way to configure that container, but in this case, I chose to use the Java config. So I'm starting up, on start, I'm starting up the Spring container, and then you'll see this other method here is what actually handles a request. So when I need to get a controller instance to handle a request, this is going to pull that bean out of the context, out of the Spring context, and then hand that request over to that bean. So let's go take a look at my config real quick for Spring. So I've got just the basic app config here that's setting up the component scan, telling it which packages to look for things in, and that's all that one does. And then the data config is what's setting up JPA for this application. So pretty basic config there. So let's take a look at how this application actually handles a request. So I have this GET request. When I load this page, a GET request comes into slash. So that in the conf routes file was mapped to a controller. So let's go check out that controller. So that's in application.java. So here I'm using the auto-wired annotations in Spring to bring in a bar service. That bar service is what is actually responsible for saving bars and getting bars out of the database. So let's go take a quick look at that one. So here over in services, go to bar service. That's my interface, and then the implementation here. So you'll see I'm using a transactional service here with a persistence context that's provided from Hibernate and JPA, and then I have a method to add a bar, which is just saving it into the database, and I have getAllBars, which is doing a query and giving me back my list of bars. So that's my service. Let's go back to the controller and see how that's implemented. So here in the index method, so that's what happens when I make that request to slash. I am returning OK, that's a status code 200, so I'm saying return OK, status code 200, and then I'm rendering a template and giving it a form for that bar.class. We'll see how that's actually rendered, how that actually results in this form being created in a minute. There's two other controller methods here. There's an add bar. What the add bar method does is it's going to bind from the request. So the request parameters that come in from the browser are going to be bound into this form, and then I can get an instance of bar out of that form. And this is where I would be able to handle any validations or any kind of validation logic that I have, and returning errors back to the user if they haven't correctly filled in the right values or required values or the right types of values in there. And then if everything is good with that bar, then I save it into the database, and then I just redirect back to the index page. This is one important thing about Play, is that when I do this redirect, I'm not actually hard coding a URL into my application. I'm not using a string. This is, something that traditionally building web applications has been a problem, where you don't have a way to have type-safe routing information. So if you change routing information, then some of your application could break because you may have forgot some place to update a route. And Play, that conf routes file actually gets compiled. So not only is the conf routes file type safe and would give us compile errors if it can't compile it, it also compiles into a reverse routing table, which allows us to reference all of that routing information through code, so that whenever we change the routing information, it'll automatically be updated throughout our application. And then finally, there's a list bars method. The list bars method returns OK, status code 200, and what it does is serialize that list of bars into JSON, and we can actually try that out by going to /bars. So there we go. Now we see my list of bars there as JSON. So this application is actually using JavaScript to fetch that JSON and then render the list of bars in the page through jQuery. So that's my controller, pretty basic. Let's go take a quick look at the views in this application. So I have this page that's actually being rendered when I go to localhost 9000. And so this is the page that's actually being rendered. We'll see that we're giving it that form, and then we're using another template here. So that app main says use this main template here. You'll see that the default templating language in Play is Scala. Scala makes for a really nice templating language, even if you're not familiar with Scala. It's a pretty simple syntax and templates. And you can also swap out that Scala templating language for other templating languages if you want. There's a number of different options there. You could use Java or Groovy or Dust or many other different templating languages, but Scala is the default templating language in Play. So you'll see where I'm bringing in the JavaScript file that's actually making that AJAX request to the JSON, and then the UL is where I'm going to put my list of bars, and then you'll see that I'm using a UI form helper in Play to display the form to get the name of the bar that then gets added to the database. The main.scala.html file is really just a boilerplate page that I'm extending from the index.scala.html. So I'm taking the content from the index.page and putting it here into the main page, and so that's how we get our boilerplate for this web page. So the Scala templates are composable, so if I had a number of other pages, I could compose these together by taking a bunch of pieces and building on top of them. So that's my views. That's how I actually render that web page. And let me show you the last part of this little app is the model. So this is just a standard Hibernate entity with using the JPA annotations on this entity. You'll see that there is a constraint there, making sure that that name is required. And so I would get a validation error in my controller if the user didn't specify a name. So that's the code for this application. It's a pretty basic little application. I want to show you one other little piece here. So let's go back into my controller. So one of the really nice things about Play that I mentioned is that in Play, when you make a change to the code and then recompile the code, you can hit refresh in your browser and automatically see those changes. So let me make just a real simple change to this application. I'm going to set the bar name to, let's say, hello plus the bar name. And I'm going to hit save here in the browser. So that'll recompile, but then all I have to do is go to my browser and hit refresh. And as soon as this application is recompiled, then we'll see that there. So let's test that out. So there we go. There we see my new bar that was created now with that hello. So that's a pretty simple example to show how we can make changes to code, hit refresh in the browser, and then instantly see those changes. So that's it. That's our quick little intro to Play. Let me show you one other quick thing. If we do want want to have tests, this application does have tests. We can put those in the test directory. Those tests get run by Activator, and you can also run those in your CI system. They're just standard tests for this application. So feel free to explore that more on your own. So that's Play. That's your quick intro to Play. Let me dive next into Akka. So Akka is a system for managing your concurrency. It has fault tolerance built in, so it's resilient by design. It's high performance, can do a ton of messages per second and have many different actors in the system. It has clustering, so you can now cluster your actors across a number of different machines. So it's really a way to manage the concurrent parts of your application, manage where you have state in your application, and manage where things aren't request-based, where you have life cycles that aren't request-based. So the core system of Akka is based on the actor model. It's a model for concurrency that's existed for a long time. What it is it's an event-driven system. So it's kind of like having a message system in your application. So what you have is these actors, and these actors, the way that you interact with an actor is that you send it a message. An actor can only process one message at a time, so what this allows us to do is have a nice way to deal with the state in our application and not have to deal with managing threads and all that stuff on our own. So you can have millions of actors in an actor system, but each one of those actors will only process one message at a time. That means that these messages, as you send it messages, these messages will queue up, and as an actor after an actor processes a message and then is available to process another message, then it will handle that. So this really manages your concurrency for you. There's a number of times in an application when you have some state, you need to work on that state, and you really only want one thing working on that state at a time. Otherwise, you get into deadlocks and race conditions. So that's really what actors are helping you to do. Actors also have a resilient system and supervision system built into them. So the default supervision system of an actor is that there's a supervisor that watches an actor, and if that supervisor sees that the actor has crashed or stalled or something has gone wrong with that actor, the default is to just restart that actor. So that's the default. You can also write your own supervisors as well to supervise your actors however you want. So the idea with actors is that you can scale up and you can scale out. You can add more actors to your system as needed. You can go to additional nodes as needed. You can send messages across nodes and process messages that way. So with actors, you can configure the thread pools, configure how many threads you're going to allocate to each part of your actor system. Actors are great for managing the non-request-based lifecycle parts of a web application. So we'll see an example towards the end where I have part of my application that's happening out of band, out of a request cycle, and actors are a really nice place to have something that isn't necessarily part of the request cycle. Maybe something that needs to happen on a smaller scale than a request, like going to a database and getting some data, or something that happens on a larger scale than a request, something that maybe is the duration of my full life of the application, or some part of my application, or some scheduled job or something like that. So actors give us a way to manage that life cycle. So let's actually dive into an example now through Activator. So I'm going to go back to Activator. I'm going to select to create a new application here. So this time I'm going to choose, again, a Spring example, but I'm going to choose a Spring and Java and Akka example. So let's go create this one. And again, I'm going to put this on my desktop. And I'll hit Create. So here we go. Again, I've created a copy of this template, and now it's my application. I can make whatever changes I want to. To this application, I can follow through the template. This one does have a template that's not under, or a tutorial that's not under construction, so feel free to walk through that on your own. Another homework assignment for you. But let's walk through some of this code in this application so you can see what's actually going on here. So first of all, you'll see the build.spt again, where we define the dependencies, and then let's dive into the source code. So the source code you may have noticed in the Play application, the source code directory, the default source code directory was just app. And in this application, the source code directory is source main Java. So that's probably, if you're a Java developer, that's probably what you're familiar to is the source main structure. And you can, of course, make Play use the traditional Maven layout for your source code as well. Just the default is app. So here's the actual Java code for this application. Let's go take a look first at the code, and then we'll run it and see what happens. So this is just a standard static void main console application. What I'm doing is I'm creating a Spring context and setting that up, having it scan for the Spring configuration and Spring parts of this application in the sample package. I'm setting up my actor system, so the root of every actor system is what's called an actor system, and then actors are built in hierarchies underneath the actor system. So the first thing that I do after I create my actor system is I want to create an actual actor, and you'll see that I'm getting a actor ref. So what I want is not the actual actor myself. Whenever I interact with actors, I interact with them through a reference rather than an actual instance to the actor. The reason for this is that this actor may not actually be local. It may actually be somewhere on the cluster, or it may the actual actor may have been restarted by its supervisor. And so if I was working directly with instances, then I wouldn't be able to handle that failure. I wouldn't be able to be reactive and be resilient. And so what I do when I work with actors is I always work with them through the actor ref, a reference to the actor. So now that I've created my actor ref, what I do is I want to send it a message. And so in this case, the message that I'm sending it is a count. I'm saying, hey, do a count. And we'll see the actual actor and the message in a second. But I'm doing that 3 times. I'm sending it 3 messages. So remember that actors will only process 1 message at a time. So these are actually going to happen not in parallel, but sequentially. And if we wanted to do things in parallel, the way that we would do that is have more actors, because of course we can run multiple actors at the same time, and each of those actors can process their own messages concurrently, but a single actor can only process 1 message at a time. And the reason for that is so that we're only working with our mutable state by 1 thread at a time, so that we don't get into deadlocks and race conditions. So then this application, what it does is it waits up to 3 seconds, and it asks this actor to get the value. So it sends it a message. The way that we always interact with actors is through messages. So we're going to send it a message and say, get me the value, and then we're going to let it wait for up to 3 seconds in order to get that value out of the actor. So that's it. That's pretty much all we're doing here in the application. Then we shut down the actor system, and that's all. So let's take a look at the actual actor. So here I have this counting actor. You'll see that my counting actor extends untyped actor. And then I have these static classes in here. These are my actual messages. So I'm using static classes as the way to send messages. Every message is essentially an object, and so I've created these classes that I'm using to now send around. So back in the main, you'll see that I create a new count, and that's the message that I send to it. You'll see this null here. That null is the sender of the message, which in this case we're outside of the actor system, so we don't have a sender in this case. So back in the actor. So in this actor, we've got our messages, we have this counting service, and this counting service is actually being injected by Springs. You'll see where it's doing that there. So that's how this is wiring in with dependency injection in Spring. That's purely optional. Just like in Play, you don't have to use Spring, you don't have to use dependency injection, up to you, but I wanted to show the Spring example since many of you are probably using dependency injection in Spring. So here in this actor, I have some state. In this case, my state is a count. And this count, I want to manipulate this state. I want to add to this count every time. You'll see down here, whenever I get a count message, I'm going to increment that count value. And so I really only want one thing to manipulate this state at a time. We could certainly get into race conditions if we allowed multiple threads to come in and change this count all at the same time. And so by putting this inside of an actor, we've made sure that only one thread is going to be manipulating the state at a time. So that the message handling here is done in an onReceive method. So the actor has an onReceive. It takes just a message, and then I'm going to look and see what type of message it is and then do something based on the type of message. So if the message is count, then I'm going to go out to my counting service, increment the count, and then update my state. If the message is a get, then I'm actually going to get the sender, so whoever it is that's asking for this, I'm going to tell that's going to send a message back to the sender with the count value. So that's how we can actually get the state out. But again, that's going to happen in a message. It's going to happen sequentially to the others. So in this application, what it's going to do is send all three of those count messages, and then it will send a get message. And once all three count messages have been processed, then the get message will be processed, and then we'll be able to get the count back out. So let's go take a look in here at the run dialog. We can see that, hey, it ran the application. Activator did that automatically for us. And we'll see down here at the very bottom it says that it got back 3. So that means the count was 3 when the application exited. We can restart this application to make sure it's still working, but there we go. We see it run again. We'll see it setting up the spring context. And then, hey, we got back 3 again. That's great. That's what we wanted to see. So that's our quick little introduction to actors and Akka. There's, for both Play and for Akka, there's a number of other templates inside of Activator that you can explore and learn more about those technologies in a lot more detail. So I'd encourage you to check out many of the other templates inside Activator to go further with learning Play and Akka. So I wanted to spend a little bit of time talking about the tools in kind of around this ecosystem that you can use to build these applications. So of course you can use Eclipse and IntelliJ or any text editor that you want when you're building applications with the Typesafe platform. And let me show you how to do that actually real quick. So inside of Activator, if you go to the Code tab and then you click on Open, then you'll see that you can open this project in IntelliJ or Eclipse, and that will walk you through creating the project descriptors for the application, and then you can open the project up in your IDE. And what most people do is they leave Activator running because that's going to run the tests and run the compile and run the application, and then they edit the code in their IDE of choice or their text editor of choice. So that's how most people are doing it, but up to you how you want to do it. Okay, so that's the tooling support for the Typesafe platform. Of course, the testing support is really anything that you want that works on the JVM. So if you're a Java developer, you're probably familiar with JUnit, so that would be something that's certainly supported. If you take a look at those two templates that I just showed you, they use JUnit for their tests, so pretty simple. And then if you want to use other testing frameworks on the JVM, there's many different ones to choose from. They should all work just fine with the Typesafe platform. So for you existing Java developers out there, really nothing new on the testing front. For build infrastructure, SBT is the default build for the Typesafe platform. It's the build tool that we use. It's a reactive build tool, makes it really easy to have that experience where you just hit refresh in your browser to see changes in Play. And then you can also use Akka as a library in an application. You can use Maven and Gradle in that case as well. For build infrastructure, both Jenkins and Bamboo support the ability to build Typesafe platform applications either through SBT or whatever build system you're using. So really, test-driven development, CI, continuous delivery, all that stuff works really well on the Typesafe platform and shouldn't be really any different from what you're used to in the traditional Java environment. For deployment, Play is a containerless application, so it contains its own HTTP server. It's based on Java NIO and Netty, and so when you deploy Play applications, you don't deploy them into a container because Play doesn't need a container. It runs its own HTTP handling. So there is a very easy way to deploy a Play application. All you do is you run activator dist. That will create a distribution of your application, which could be a zip file or a tar.gz or whatever format you need, and then you take that file, upload it up to your server, extract it, and run it. And then that's kind of the simplest model. You can, of course, integrate CI and continuous delivery into that as well, where you can have your CI system running that same task to produce those artifacts. So up to you how you want to do it. So Akka now with Akka 2.2 supports clustering, so you're able to now deploy Akka applications across the whole cluster. So for monitoring, there's a lot of different options. There's the Typesafe console. I'll show you that in a couple minutes. There's New Relic, Taka-P, and App Dynamics for monitoring Play and Akka applications in production. So these tools allow you to actually hook into a production system, be able to get errors, see how long method calls are taking, some pretty fancy tooling for troubleshooting and dealing with production issues. So those are the kind of tools, as you probably saw. It's things that are pretty familiar to you as a Java developer. So with that, I want to jump into another application here inside of Activator that will kind of bring some of this stuff together. So let me go back and create a new application here. So I'm going to choose the Reactive Stocks application here. So this is a sample application that's part of Activator, and let me go put that on my desktop here. There it is, and hit create. So there I have my Reactive Stocks application, and again, you can go through the tutorial on your own to learn more about this application. But I want to show you how now we can combine both Play and Akka together, combine actors, combine a web application together into one cohesive application. So the Reactive Stocks does that, exactly that. It's a kind of end-to-end Typesafe Platform application that shows you how to do everything you need with actors all the way out to WebSockets and REST. So some of the Reactive Stocks application is written in Scala, some of it is written in Java. I'm going to just be showing the Java parts of it today. Of course, anything in this application that's written in Scala, you could certainly also write in Java. We chose to make this one a mixed application just so you can see kind of some of the differences in how you write the Typesafe Platform applications between the two different languages. So the application is now compiling. We'll see the structure is pretty similar. We have a build.spt, which defines our dependencies. We have the traditional Play structure with an app directory with all my source code, conf directory, project for additional build information. That my application is compiled. It's now running the tests for my application. We'll see the test output here in a second once all the tests are run, and then it will run the application and we'll be able to check it out. But while it's waiting to get up and running, let's go now check out some of the code for this application. So first of all, you'll see that there's a conf routes file, very similar to the one that you saw for the first Play application. We define some routes here. So there's a get handler for slash, which goes to controllers.application.index. You see that I'm not using the @ notation here, so that means that I'm not using dependency injection in this case. Up to you which way you want to do it, but this one is just using a static method. This application, the Reactive Stocks application, uses a WebSocket. So WebSocket is just initiated with an HTTP GET. So I'm making a GET request to /ws and handling that with application.ws. And then that will show how to do reactive push, the WebSocket, but on the Typesafe platform you can also do what's called reactive composition and reactive requests. And this line 7 here shows how to do reactive composition. Let me show you the application so you can see that part of it. So let's go open up the application here. So here's the Reactive Stocks application. It's simulating some stock values, and what I can do when I click on one of these stock values is it's going to fetch tweets about that stock symbol and then do sentiment analysis on each of those tweets and then tell us based on the sentiment whether we should buy, sell, or hold the stock. This is just a fun demo, so please don't use this for any stock buying decisions. So there we go. We should hold Apple according to Reactive Stocks. So when I do that request to go out and fetch the tweets and do all the sentiment analysis of those tweets, there's a bunch of requests that are going out, and what that's really showing is that I can do async and non-blocking across all of those requests. So the whole request pipeline becomes async and non-blocking. And you can check out more about that in the tutorial and in the code for that on your own. So this is the Reactive Stocks application. Let's go check out some of the other code behind this application. You'll see that it's pushing values in real time out to the client using a WebSocket. So let's go see how that actually works. So let's go into app and then controllers and then application.java. So here's the method that I want to show you. You'll see that this looks pretty familiar to what you saw in the first Play application, but in this case what I'm doing is I'm setting up a WebSocket. So this WebSocket is going to communicate using JSON, and what I'm going to do is when the socket is ready, so when the connection is open, I actually create an actor. So this is similar to what you saw before. I'm going to create an actor in my actor system, and my actor is going to be a user actor. You'll see that now that's an actor ref that I can use to send messages to that actor. And then there's a few other things that I do with this WebSocket. If I get a message from this WebSocket, the place where I get a message is when I go in and add in a symbol to this. So I just added Adobe that sent a message over the WebSocket. So what actually happened was this went into the on message handler, and then it set up a new stock and is now watching the stock. So it's just doing that by sending messages to actors in the system. And then finally I have an on-close handler so that if this WebSocket closes or when this WebSocket closes, it will tell the actors to clean themselves up. So I've got this actor for every user that's connected, basically every WebSocket that's connected, and that allows me to send messages through the WebSocket there. And so when the user disconnects, I want to clean that all up. So that's what that does. So that's my controller. That's how I'm setting up the WebSocket and communicating with the WebSocket. But let's dive into the actual actor underneath this. So I have this user actor here. You'll see that I'm passing it an out reference. So out is the handle to my WebSocket that allows me to actually push messages down through the WebSocket from the server down to the client. This actor's life cycle is not based on a request. It's based on the duration of the WebSocket connection, which will be as long as the user has this tab open in their browser. As long as this WebSocket is open, this actor is going to stay alive. Up to you how you want to control your actor life cycle. They can be very short-lived. They can be long-lived like this one. Totally up to you in what your use case is for how you use these actors. So I've got my user actor through an actor ref that allows me to send it messages. You'll see that that I'm passing it as a sender to this case, and that's how I'm communicating between the stocks actor and the user actor. But let's go jump back here and take a look at the actual actor code for that user actor. So first of all, you'll see that this actor is just like the first one that you saw, an untyped actor, and it has some state in it. So this handle that I have to this WebSocket out connection, it's some state, and actors give me a good place to manage that state and be able to make sure that only one message, only one thread is going to be using this state at a time. So in this case, that's just a property in this user actor. You'll see that the constructor there is where I pass in that state, that handle to the WebSocket. You'll see that when this user actor is created, I want to watch some default stocks. So you'll notice, you may have noticed when I first loaded that application in my browser, I had 3 stocks that were automatically being watched. And the way that that happened was I looked up in my configuration file for the default stocks to watch, and then I iterated through those, and I sent a message to the stocks actor and said, hey, watch each of those stocks, and the sender of that message is me, this actor. So then I have my typical on-receive method. So the main thing that this user actor is responsible for is sending messages through that WebSocket out channel. I could also, of course, handle the in channel if I wanted to process messages in this actor, but in this case, the primary thing this actor is doing is just being basically a broker to serialize these messages that the actor is getting, serialize those into JSON, and then push those out in real time down to the browser through the WebSocket. So if I get a stock update message, then what I'll do is I'll serialize that into JSON, and then I'm going to call out.write, which will write that message into the WebSocket channel. And same thing for a stock history. If I get the full stock history when the application first starts, if I get that message, I'm going to serialize it into JSON and then push that out through the WebSocket channel. So that's really most of the Java side of this application. You can, of course, explore the Scala side, the stock settlement service, which is written in Scala. You can also explore the stock actor, which is written in Scala. Again, we just did the Scala in Java so that you can be able to kind of compare and contrast the differences between those two, but certainly the whole application could have been written in Java. Okay, so we've got our application, it's up and running, but I want to show you the Typesafe console because one of the challenges with asynchronous reactive programming is understanding how messages are flowing through a system, understanding how many messages are going in and where those messages are going and how long those messages are waiting to be processed by an actor. And so let me show you the Typesafe console because that's the way that we can visualize this information. So you'll see in the run part of Activator, I can restart this application with console. So I'm going to click that. So this will actually now restart my application with the Typesafe console enabled. So once that's done, we'll have to reload this application in our browser because we just restarted it. So let's go just hit reload here. So that'll load that application back up. And while that's loading, let's go open up the Typesafe console. So the Typesafe console allows us to visualize exactly what's actually in our application. So this is the UI of the Typesafe console, and what it'll start doing is it's actually looking at my system, it's looking at my running system, and it sees exactly what's going on. It sees all of the nodes in my system, so if I'm running a cluster, I would see all of my nodes. It sees my actor systems, it sees my dispatchers, and my actual actors. And now we can actually dive into the different parts of this application. If I want to dive in and see my actors, look, there's an actor for each of the stock symbols that I'm watching. There's an actor for each of my users. So here is my user that has my WebSocket. And now I can even dive into these actors and see the throughput of messages. I can come in and see the actual details, how many messages are in the mailbox. Over time, I can see how long those messages are waiting in the mailbox, how long it's taking to process each message. So this really allows me to dive into my system and see exactly what's going on the internals of my application for the whole actor system. So we can also visualize play. So we've got a play application here as well, and you'll see that the Typesafe console has a way to dig in and see what exactly is going on inside of my play application. So in this play application, I have some controllers. Let's go make a few requests. Let's go do the stock sediment. Let's go make a couple of requests here and come back here, and we'll see that once the information has been instrumented, it'll come in here and we'll be able to dive in to see. There we go. Okay, took a second for it to synchronize all that. It doesn't do it all at once. It kind of batches things together, but now we see there's all my requests that have come in, and now I can actually dive in and see, hey, there was a GET request to /sediment/goog, and now I can actually dive in here, see how long it took to execute that request, what the request headers were, really dive into all of the details of my play application as it's running and as it's being used. So the Typesafe console, it's super easy to enable through Activator, allows you to really dig in and see the internals of your application as it's up and running. So with that, I wanted to show you the Reactive Stocks application, show you how to do the Typesafe console. Again, you get that through Activator. Just go to typesafe.com. You can download Activator. You can extract the zip file, start it up, and then start building applications based on those 32 templates that are there inside of Activator. So the Typesafe Reactive Platform, it's enabling us to build reactive applications. Reactive applications that react to events, react to load, react to failure, and react to users. And that's really what where software is headed. And so we're glad that you're able to be part of this. But thank you. Try out Activator, and we're going to take some time now for some questions. So so bear with me while we look and see what some of the questions that have come in. And you can type those into your chat pod, so feel free to send in questions, and we've got about 9 minutes left for those. So there's a question about how we work with Play in a multi-developer environment. The typical structure is that each developer, they're going to be working on their local machine. They're going to have Activator. They're going to have their IDE. They'll pull out the code from a source control system and pull that to their local machines. They'll be working on the code locally. You can choose to set up local databases. If you have any resources that the application needs, you can set those up locally. And then the user will make their changes, they'll test their changes, and they'll check their changes into a source control system. The typical way that we do this in an enterprise at that point is that by checking into a source control system, that will kick off a CI build with Bamboo or Jenkins, and then run any other tools that need to happen. And then the CI system will generate an artifact. We'll typically take that artifact that's generated, the zip file that's generated for Play, in the case of Play, and we can copy that zip file, or we can set up other ways to do distribution as well, but we'll take essentially that artifact, we'll put it onto a staging system, we'll test out that artifact on the staging system, make sure that everything is okay, and once we've verified that everything is okay, then we can take that same artifact and deploy it onto a production system. There's certainly some other tools out there that will help you deploy application, play and Typesafe platform applications. There's tools to look into like Mesos and Ansible Works. We're actually doing a webinar tomorrow to show how to do Typesafe platform with Ansible Works, which will help you do that. So really, this isn't too different from what you're probably used to in the Java ecosystem. You're going to do the usual flow of working with a CI system, having that automatically build and produce your artifacts. You of course don't have to do it that way, but in an enterprise that's the best way to work with a team. The one difference for play applications is that you do not deploy play applications into an existing container. You run them as standalone applications because they run outside of a container. Really, this facilitates doing continuous delivery. So containers make it hard to deliver software quickly, and Play Framework being containerless makes it really easy to update and roll out new versions of your application. So there's a question about Akka and fault tolerance. Let me provide a little bit more detail about that. So when you send a message to an actor, the actor system is going to make sure that there is an actor there. So, or once you've created an actor instance, the actor system will make sure that there's an actor there. So if for some reason you crash that actor, let's say you throw an exception and that crashes it, or let's say that it times out, it just takes too long, or something happens where that actor crashes, the default supervision strategy is to actually restart that actor. You can change the supervision strategy, but it's up to you. The default one will just automatically restart it, and then we'll continue processing messages. And there's also a follow-on question to that about guaranteed delivery. So there is some documentation on how to what you do if you need messages to be fault tolerant. You can persist those messages. That's in the Akka documentation, and you can check out more about that as you want. So there's a question about large projects. So we know that there's a number of people out there that are building very large applications with the Typesafe platform, and the best way to manage that, these large applications, is to use multi-project setups. So you'll have projects for libraries that are common. You'll have projects for, let's say, the admin part of the application. You'll have a project for the user part. You'll have a different project for another part of the application. You may have a project that's just kind of some back-end big data cruncher actors, and so you can partition your structure of your application out into a number of different pieces. This is really, in the Typesafe platform case, this is facilitated through SBT and the multi-project support in SBT. There's some questions about Activator and the code editing environment inside of Activator. So the code editing environment in Activator it's a very, very simple, basic code editor. We certainly expect that most developers will be using Eclipse or IntelliJ for most of their code editing. So the one inside of Activator, it's really there to facilitate you as you're walking through a tutorial, make that process super simple and easy. But most developers, if they're in code all day long, they're going to be in a better IDE, or in a real IDE like Eclipse or IntelliJ. So yes, I definitely encourage you to use Activator with an IDE and not just the Activator code editor. So follow on to that is debugging inside of Activator. So Activator doesn't have debugging in it. If you want to do debugging, it's really easy to set up. You just run your project in debug mode, and then you can connect to a remote debugger from your IDE to be able to hit breakpoints and that sort of thing. So there's a question about Akka in distributed environments. So Akka 2.2 added clustering support, and there's actually some really good tutorials and templates inside of Activator for how to work with Akka in a distributed system. So I think the name of it is Distributed Actors, and then there's a Java one and a Scala one. So I'd encourage you to check out those templates inside of Activator, and there's some great tutorials along with those. So there's a question about, can the Typesafe console be hooked up to a regular Akka application on Tomcat? And I believe so. I've never tried that myself. Certainly you can use Akka as a library just in any Java application. And I believe that it's possible to run the Typesafe console when it's running inside of Tomcat. There is a page on typesafe.com that has more documentation on the Typesafe console, and so I'd encourage you to check that out on the typesafe.com website. There's a question asking, is there any issues using Activator and Eclipse together? And not that I'm aware of. If there are, Activator is open source on GitHub, so it's github.com/typesafehub/activator, and I'd encourage you to file any issues if you find anything wrong with Activator plus Eclipse. There's a question about handling multiple nodes with Play and the Typesafe console. I'm pretty sure that works. I haven't tested that personally, but I think that should work just fine. Let's see. There's a question about dependency management in SBT and Play, and it's the way that SBT pulls in dependencies is it uses either Ivy or Maven repositories. So this means that you can put it on top of Maven Central is what's there by default, but you could also put it on top of Artifactory or the Nexus product. Up to you, but it should work just in the, if you're familiar with Maven, it should work in the same way as you're used to with Maven. You have repositories that have dependencies. SBT and Play should be able to pull those dependencies out, no problem. There is a question about the licensing. So great question. The Typesafe platform is open source. It's composed of open source components. So there's Play Framework is open source, Akka is open source. And so you can use those products as open source. And then we also have a commercial subscription for the Typesafe platform, which will license it under commercial terms, give you support and assurance on that product. So you can check out more about that on the typesafe.com website. There's a question about Play 1 and Play 2. Play 1 and Play 2 are pretty different products. Play 1 had some great ideas and was great. It provided the first kind of Ruby on Rails style of development for Java applications. Play 2 was really a whole new product. It took some of the same ideas, but really rebuilt some things, and so they're really different in terms of migration from Play 1 to Play 2. There are some places where that's painful because it's such a new product. There was the authors of Play were even considering not even calling Play 2 Play because it was so different. But there are some things to make that a little bit easier. One of them is that you can use the Groovy templating system in a Play 2 application, which allows you to have the same kind of templates in Play 2 that you have in Play 1. So there is a little bit of a way to migrate, but there is a lot of differences. So there are a bunch of other questions. I'm sorry I didn't get to all of them, but what we'll do is we'll actually be able to email you, or you can email me, james.ward@typesafe.com, if you didn't get your question answered, and we'll try to follow up with everyone who didn't get their questions answered as well. So I hope this was useful for you. Thanks so much for attending. We'll be doing more of these, so stay tuned on the Typesafe website. And this will also be recorded, so if you want to rewatch it or send it to your friends. So thank you so much for attending. Hope it was useful. Have a great day. Thanks.